Good morning, students. Till now we have discussed P block elements, and in P block elements we have discussed group 15, 16, 17 and 18. So we all know that our periodic table is divided into various groups, that is S block, P block, D and F block. So after covering the section of P block elements, we are going to discuss D and F block elements. According to the revised syllabus, many topics of F block elements have been curtailed. So we will first discuss about D block elements. What do we mean by D block elements? Like we have studied in P block elements that what are P block elements? Those elements in which the last electron enters in p orbital are included under P block elements. Here the same thing goes with that is D block elements. That is, when the last electron enters in d orbital, then those elements are included under D block elements, right? So D block elements are more popularly known as transition elements because transition means intermediate, in between, because transition elements or D block elements are present between S block elements on the left hand side and P block elements on the right hand side. So in between D block elements are present, that's why they are known as transition elements. Whereas F block elements consist of lanthanoids and actinoids. You must have seen that in periodic table there is a separate place or separate block for F block elements. Those are also known as inner transition elements because they arise from D block elements, or they are in between the D block elements, and we have extracted them out from D block elements. And you must have also seen the gap in between two D block elements, and this gap is due to the presence of F block elements. We will see how in the periodic table they all are arranged, so that you may have a clear picture of how D and F block elements are arranged in the periodic table. This is periodic table. You can see that first two groups, that is S block elements, consist of group number 1 and group number 2. Then comes group 3 to group 12, that is present between S block and P block elements. The whole purple block from scandium, that is in the 3rd group, to zinc, that is in the 12th group. ये जो सारा block है, this whole block consists of D block elements. Now you can see that scandium in the 3rd group, उसके नीचे yttrium, lanthanum and actinium. ठीक है, we are concerned more about D block elements from scandium to zinc, yttrium to cadmium and lanthanum to mercury. And the first series of scandium is known as 3D series, then 4D series of yttrium, and then 5D series of lanthanum. You can see that in lanthanum atomic number is 57, and just after that it is HF, that is hafnium, in which atomic number is 72. So where is the element in between that, and why there is so much of gap between these two elements atomic number? So the answer here is that because of the separate position given to these elements, and they are discussed as inner transition elements, क्योंकि ये D block से ही निकल के बाहर आए हैं, and D block को we are saying transition element, and ये हो गए हमारे inner transition element. So you can see 58 से लेकर 71 तक ये होंगे lanthanoids. And come to the next line कि actinium में भी यहाँ पर atomic number of actinium is 89, and then comes RF, that is Rutherfordium. इनके बीच में भी there is large gap of atomic number. This gap is because the elements are placed here, which are known as actinoid 2nd series, from thorium to lawrencium, right? So we are basically concerned with D block elements for now, from group 3rd to group 12, right? Group 3rd से लेकर group 12 तक we are having 10 elements in total, and you have to remember the atomic number as well as the name of the elements. And since you are very lucky that actinoids are completely we can say almost 90% F block elements or actinoids is removed, so you just have to concentrate your study on the D block elements. So D block elements where we are going to study physical properties, why they are known as transition elements, what is the sequence of their atomic radius, what are their different physical and chemical properties. So before reading that, it is must that you should be knowing names of all the D block elements. You should be knowing all the atomic numbers of the elements, so that whenever any element, if I speak out, that is if I speak MO, that is molybdenum, so you should know where is molybdenum present in the first series, second series or third series, and what is the atomic number of molybdenum. And there are some elements that have exceptional electronic configuration that are very important from exam point of view, because if there is any normal element and they are asking you electronic configuration, that doesn't make any sense. But if there is any element that have some exceptional electronic configuration, that is very important from the exam point of view. So this was about periodic table and the position of D and F block elements. Next, we can say the elements of periodic table from group 3 to 12 are known as D block elements, and as I have told you, the last electron enters in the D subshell or D orbital, and they are present between, or they are flanked between S and P block elements in the long form or modern periodic table. This is first series, second series, third series and fourth series. As I have told you, there are total 10 elements in the first series. I'm taking the name of elements, just learn the names and the atomic numbers as well, and the electronic configuration. You don't have to remember 1s2, 2s2, just remember the outer electronic configuration, because if the outer electronic configuration is known to you, inner orbitals can be filled easily, right? So scandium, atomic number 21. There is a trick to remember these atomic number, just write 4s and 3d, right? And we know that last electron should enter in D orbital because these are D block elements. So you see, scandium consists of 21 to 122 to 121. To 4s mein we will write 2 and 3d mein we will write 1. Titanium mein 4s and 3d, 4s mein write 2, 3d mein write 2. Vanadium 23, 4s में write 2, 3d में 3. Chromium is 24. Now put a star in chromium wherever you are writing or you are learning, because chromium is an element with exceptional electronic configuration. It should have configuration 2, 4, but it is showing 1, 5, because one of the electron from 4s goes into 3d. As we all know that completely half filled or completely full filled electronic configuration is extra stable. Then comes manganese. Manganese में 2, 5, of course it is according to the normal sequence. Iron Fe 2, 6, cobalt 2, 7, 4s में 2, 3d में 7, nickel is 28, 4s 2, 3d 8, copper is 29. Again put a star here because copper also have exceptional electronic configuration, that is 4s में 1 and 3d में 10 electron. It should be like 2 in 4s and 3d में 9, but 1 electron from 4s is getting transferred to 3d for achieving completely fulfilled electronic configuration, right? Then comes zinc. We cannot write 3, 0. Why? Because 4s में या s orbital में there can be maximum of 2 electrons and it cannot be exceeded. And 3d में we cannot write 0, because since we are writing electronic configuration of D block elements, so if there is 0 in D or no electron in D, then how can we tell that this element is from D block element? So the electronic configuration of zinc is 210. Next is second series. Now in the first series the elements were from the atomic number 21 to 30, and then in second series the elements will be from atomic number 39 to 48. First I will speak out the names of these elements so that you may find it easier to write their electronic configuration. It starts from yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver and cadmium, right? In yttrium atomic number is 39. It consists of electronic configuration 2, 1, zirconium 2, 2. Niobium is again an exception in which electron from 5s goes to 4d. We are seeing, put a star here, we are seeing that there is no half filled configuration, but still there is transfer. Yes, there is exception. Molybdenum, we can see 1 5, it should be like 2 4, but it is 1 5. Molybdenum is an exception because it is half filled electronic configuration. Now you can see from niobium till silver there is not general electronic configuration going on. So this part is very important from exam point of view, because it's not like 2 3 2 4. We are seeing that from niobium 5s orbital is containing only one electron. In molybdenum there is also one electron, technetium 1 electron, ruthenium 1 electron, rhodium 1 electron, and in palladium it becomes entirely 0 because it have to transfer electron to 4d to get completely fulfilled electronic configuration. Then comes silver. Silver is also having 1 electron in 5s and 10 electrons in 4d. That makes 5s half filled and 4d full filled. Then comes cadmium. Cadmium is fully filled by 210. Come to the third series. Third series is again important. Why? Because lanthanum here having atomic number 57, and then comes hafnium with atomic number 72. We can say there is a gap of 14 elements in between. Why there is gap? Because these 14 elements are present in the F block elements, or they are placed according to their properties separately in the periodic table. So hafnium and lanthanum have gap in between that. This gap is often known as inner transition element gap, and the atomic number of these elements, like lanthanum 57, 6s have 2 electrons, 5d have 1 electron. Again here in the third series I will mainly concentrate on the exception which is present, and exception you can see in platinum. Platinum, it is having 1 electron in 6s and 5d में 9 electrons. Exception is there in gold. It is also having 1 electron in 6s and completely fulfilled configuration in 5d. So in third series there are 2 exceptions, platinum and gold, right? It consists of elements with atomic number 74. Tungsten. Tungsten, we all know it is used in electrical bulbs. Then we have rhenium, osmium, iridium. Osmium, you can write that osmium is the element with highest oxidation state of +8. Iridium, platinum, Au is gold, Hg is mercury. So this was all about today. From the next turn we will discuss a little about fourth series, and then we will come on to the topics like physical and chemical properties of D block elements. I would suggest to read the topics that are covered today from the book also, so that you can understand it in a better way. Thank you so much.